All right, so yesterday we started off with an introduction to vectors and learned some basic vocabulary, and today we're going to talk about some more basics of vectors, just some more vocabulary, that other form that I told you about, and then some other things we can find. So I'm going to call these notes more basics of vectors, just because I don't want to have a title that has a list of 4 things. So yesterday we learned about the component form, which you know was vector v is v1 comma v2. Today we're going to learn about the linear combination form, which is v is ai plus bj. And you could, this is how everyone writes it, is ai plus bj, but really if we were to relate it to the form up here, we would say that's like v1 times I plus v2 times j. So if your component form of a vector was 1 comma negative 5, then this would be 1i minus 5j. So they're very easy to switch back and forth between the two forms. I am not exactly sure why there's 2 different forms. They're used interchangeably. If the instructions do not specify which form you have to use, then you can use whichever one you like. Okay, so that is the component form. And let's go ahead, and I said an example, but let's go ahead and write it. So if we had the component form 1, negative 5, then that would be 1i minus 5j, just so we have something written down. Okay, so we're going to go ahead and learn about unit vectors. And a unit vector has a length of 1, but is in the same direction as the original vector. All right, so what I mean by the same direction is that it's at the same angle. It's just been scaled down so that it has a length of 1. So the formula here for a unit vector, we'll use u for a unit vector, is that that's v divided by its magnitude. So if I have a magnitude of 5 or a length of 5, then I can take the vector itself and divide it by 5, and that would make it a length of 1. So the way that we do this is we would say v1 divided by the magnitude of v, comma v2 divided by the magnitude of v. And that would be our new vector. Okay, so we're going to go ahead and find the unit vector of w, which is 2, negative 5, and write it in its linear combination form. So I have vector w. I need to find the magnitude of w. So the magnitude of w is going to be 2 squared plus negative 5 squared. That's 4 plus 25. So that's the square root of 29. So now I can go ahead and figure out what the new horizontal component and the new vertical component would be. So I'll go ahead and say w over its magnitude is 2 over square root 29 comma negative 5 over square root 29. And as we know, it's not proper to leave square roots on the bottom of a fraction, and so I should be fixing this. by multiplying by square root 29 on the top and bottom. And I need to change the form anyway. I wrote this part of my work in component form. I need to write it as a linear combination. So I'm going to say the unit vector of W is 2 square root 29 over 29i minus 5 square root 29 over 29j. Okay. We're also going to learn one more vector operation. This is called the dot product. And you cannot multiply two vectors together in a conventional sense. So the dot product is basically the idea of vector multiplication. Now here is what always throws students off, is if you add two vectors, you get a vector as an answer. If you multiply a vector by a scalar, then you get a vector as an answer. If you multiply two vectors together, meaning you do the dot product, so vector dot another vector, your result is not a vector, it's a single number. Okay, so the dot product is a single number. So what we're going to do is we're going to say the formula for the dot product is, we'll say that V is A1I plus B1J, and we'll say vector W is A2I plus B2J. Then the dot product V dot W is A1 times A2 plus B1 times B2. And I wrote it as a linear combination in this form, but you can do it from the component form as well. So basically, to do the dot product of a vector, you multiply the horizontal components together and get the product. You multiply the vertical components together and get a product, and then you add those two numbers, and that's how you do it. So we're going to go ahead and find, do an example using this idea of dot product. So for example, we're going to say vector V is 2i minus 3j, and W, vector W, is 5i plus 3j. And we're going to find a few different things. We're going to find V dot W. We're going to find W dot V. And we're going to find V dot V. Okay, so V dot W would be 2 times 5 plus negative 3 times 3. So that would be 10 plus negative 9, which is 1. So the dot product V dot W equals 1. You'll notice if we go backwards, we have 5 times 2, which is still going to give us 10. And 3 times negative 3, which is still going to give us negative 9. So what that told us is that multiplication, or the dot product, is has commutative properties, which means you can switch the order and still get the same answer. To do V dot V, you get 2 times 2 plus negative 3 times negative 3, which is 4 plus 9, which is 13. So what you'll notice is that V dot V is very similar to the idea of the magnitude. So that's because that's the horizontal component squared plus the vertical component squared. It just wasn't square rooted afterwards. So we're going to say that V dot V is exactly the same as the magnitude of V if I squared it, if I got rid of the square root sign. And it's not that I'm going to make you guys do that often, it's just that that question shows up sometimes. Okay, so one last thing we have to look at is how to find the angle between two vectors. So there's a formula for this, and the formula is cos theta. So theta is going to be the angle. Cos theta is u dot v divided by the magnitude of u times the magnitude of v. So that means if I want to isolate the angle, I just need to cos inverse both sides. So theta is cos inverse of u dot v over the magnitude of u times the magnitude of v. Okay? So for example, we're going to find the angle between u, which is 2i plus 3j, and v, which is negative 2i plus 5j. So u dot v is one of the things we have to find. And u dot v is 2 times negative 2 plus 3 times 5. So that's negative 4 plus 15, which is 11. We also need the magnitude of u. So that is the square root of 2 squared plus 3 squared. 4 plus 9 is 13. So square root of 13. And we need the magnitude of v, which is negative 2 squared plus 5 squared. So 4 plus 25 is the square root of 29. Okay, so we have all that information. And I'm going to go ahead, before we finish solving this problem, I'm going to go ahead and draw a picture of this so you guys can see exactly what we're trying to find. Maybe I'll just draw it on here. I was going to try to get one of my blue stickies off, but I can't get it off right now. So I'm going to draw a picture of this. So u has a horizontal component, I'm going to start it at the origin, has a horizontal component of 2 and a vertical component of 3. So there is u. V has a horizontal component of negative 2 and a vertical component of positive 5. So there's v. And then this right here would be theta, or the angle in between them. All right, so we should have a pretty good guess already as to what that angle could be. It's definitely less than 90 degrees. My drawing is not super accurate, so my drawing may not be a great guesstimator, but we'll be somewhere around there. So we're going to say cos theta is u dot v, so 11, over the magnitude of u, root 13, times the magnitude of v, root 29. And we don't need to simplify this at all because this is typically not the final answer, it's just the work to get to the final answer. So I'm not going to worry about how improper that is. And so if you plug this in your calculator, then you end up getting that this is 55.49 degrees. And we're going to move in. Once we get into calculus, we start working exclusively in radians, even if you were finding the angle between two things like this. But in this unit, we're going to go ahead and use degrees. So for all of this unit, no radians, everything is in degrees, which you could add to your notes if you need to. So we'll be working with that. There's one more definition I want you to put on here, which is orthogonal vectors. And orthogonal vectors are vectors that form a 90-degree angle. So that means they're perpendicular. So if you think about perpendicular, that would mean that theta is 90 degrees. So that means that when we do our formula, we're going to say cos of 90 degrees equals u dot v over magnitude of u times magnitude of v. And if you look at the unit circle, the cos value of 90 degrees, at 90 degrees the x-coordinate is 0, so that means that all of this would zero out. Well, our magnitudes are not going to be 0 because there wouldn't be a vector. If the length of the vector is 0, it just doesn't exist. So that means that for us to have orthogonal vectors, our dot product has to be 0. All right, so vectors that are perpendicular, this happens when the dot product is 0. So I'm going to go ahead and write that on my paper.